Hello everyone, welcome back in the second part of this tutorial on performing correlation analysis with SPSS. In first part, we have understood the concept of correlation. In this part, we will be calculating correlation coefficient in SPSS. So as you can see in the screen, this is a default screen of SPSS. We are using IBM SPSS version 21 for the calculation. It is a very widely used and user-friendly statistical software. Basically, it is graphic-based software. Most of the academic researcher they prefer to use SPSS for statistical analysis. Okay, so in SPSS there are multiple data file, a sample data set for practice purpose. So we will be using one such data set for today's class, for today's tutorial. So how we can open sample data which are inbuilt in SPSS. A simple, just go to file, click on open, then select data. Just scroll and select sections, this local disk C drive. Double click on program file, then select IBM this folder, double click on SPSS, double click on statistics, double click on 21. Then there are multiple folders. You need to select sample folders. So sample, just double click on sample, double click on English. So these are multiple data set which are already inbuilt in SPSS for practice purpose. So we will be using one dataset for today's tutorial. So there are multiple dataset as you can see in the screen, and these all datasets are inbuilt for practice purpose. So we will be using today one such dataset. This is which is advert.sav. So just double click on this advert.sav. Dataset will automatically visible on your screen. So now the data is visible. Okay, I just want to explain you this data set. So this is a data of a consumer durable company. Consumer durable company data set is there on your screen. So company has collected data of two variables for last 24 years. So last 24 years for these two variable data is collected. First variable is advert, which is actually advertisement expenses. That means company has collected the data for last 24 years, how much they have spent on advertisement. So this is a scalar in nature. This data is scalar. Again, second, we have sales data, sales revenue, which is also for last 24 years, and it is also scalar in nature. If you can see the data set, it is very simple. There are 24 observations. So this is data of 24 years. This data set explain you when the advertisement expenses of company in year 1 is 4.69 crores, then the sales was 12.23 crores. Again in year 2 the advertisement expenses was 6.41, sales was 11.84. so as all for 24 years data is provided. So there are 24 different data points in this data set. Okay, so now we want to calculate correlation. So for calculating correlation, process is very simple. Just follow the instructions. Click on analyze, go to correlate, then select bivariate. Okay, as you can see there are multiple options: bivariate, partial and distance. We are selecting bivariate. The reason is very simple. We use Pearson correlations which calculate correlation pairwise. That means two variable at a time. That means suppose we have two variable, then it will calculate a correlation coefficient. Suppose we have more than two variables, suppose we have three variables, so it will calculate correlation but two at a time. That means first it will calculate correlation coefficient between 1 and 2, then it will calculate correlation coefficient between 2 and 3, then it will calculate correlation coefficient between 1 and 3. That means at a time this will consider only two variables. That's why we select bivariate. So I am repeating it again. For calculating correlation coefficient, just go to analyze, then select correlate, then click on bivariate. Once you click on bivariate, this dialog box will appear. This dialog box is very simple. There are two boxes, this left hand side box, then we have right hand side box. So what you need to do, you just need to transfer the variable from right hand side box to from left hand side box to right hand side box. Okay, so here in this case we want to calculate the correlation coefficient between sales and advertisement expenses. So we will transfer both the variables in to this right hand side box. So for transferring or for moving the variables, we have this arrow. So we can use this arrow for transferring the variable. So just select advertisement expenses, click on this arrow, the variable will automatically get transferred to next box. So then select sales and click on this arrow. So both the variable, we have transferred both the variable into right hand side box. So now there are few options which you need to understand. Okay, the first is this correlation coefficient. So already Pearson is we already take Pearson is already selected, so need not to change anything. By default this Pearson will be selected. Okay, then two-tailed is already selected. Two-tailed means simple, whether the association is positive or negative. We are looking for both the side, whether it is positive or negative. That means we need to select two-tailed, which is already by default selected. Okay, then you just need to click on OK. So once you click on OK, the result will appear. So this is the correlation table. So this is the correlation table, as you can see, a correlation table. Okay, now it is very simple. The interpretation of this table is very simple. For that, what you need to do, you just need to identify the right cell. As you can see in this table, there are multiple cells: first cell, second cell, third cell, and fourth cell. Okay, if you can see the corresponding value of cell first, explain relationship between advertisement and advertisement. That means on both side, series or variable is same. So as you can see, because both the variable are identical, both the variable are same, the correlation coefficient is 1. Now move to second cell. In second cell, correlation coefficient is presented between what? Sales and advertisement expenses. That means cell number 2 explain you the correlation coefficient between advertisement and sale, which we want to study. The objective of our study is also the same. We want to study the association between advertisement expenses and sale. So we will read this second cell. So there are three we can say figure presented in this second cell. So as you can see that in first row, Pearson correlation coefficient is there. That means this 0.916 is the value of Pearson correlation coefficient. Okay, so as we know that positive sign signifies positive relationship. That means we can say in this case, as the value of correlation coefficient between sales and advertisement expenses is positive 916, which says there is a positive relationship between advertisement expenses and sale. Now relationship is clear. What about the magnitude of relationship? As in the previous tutorial I have explained you, higher the value of coefficient, stronger the relationship. The thumb rule is anything above 0.5 is considered to be strong. So we can conclude that there is a strong positive relationship between advertisement expenses and sale. But wait for a minute. in every statistical analysis we need to consider also the statistical significance. That means correlation is there. There is a relationship. Correlation coefficient says there is a relationship between advertisement expenses and sale, and it is strong and positive. But whether it is statistically significant or not, this we also need to interpret. So for that purpose, for checking the statistical significance of correlation coefficient, we will read second row. As you can see, significant two-tailed. So this row we will interpret for identifying statistical significance of correlation. That means first says strong correlation, strong positive correlation, but is it statistically significant or not? So for this we will be using the p-value, the significance value. The thumb rule is, if the p-value is less than 0.05, I am repeating, if the p-value in any case is less than 0.05, then correlation coefficient considered to be statistically significant. And if the p-value or significant value is more than 0.05, then we say that correlation coefficient is not statistically significant. Okay, so now you will be wondering why we compare statistical p-value with 0.05. The concept is very simple. So in research we have a confidence level. So usually in social science we apply a 95% confidence level. That means we are testing the hypothesis on 95% confidence level, which says which says that the level of significance is 1 minus confidence level. 1 minus confidence level. So if we subtract 95% from 1, so in fraction we can write 95% as 0.95. So 1 minus 0.95, the value is 0.05. That's why we compare significant value with the cutoff value 0.05. Suppose you want to have 99% confidence level. In that case, your significance level will be 1 minus confidence level. That means 1 minus 0.99. The value is 0.01. So in that case, you will compare with 0.01. But as in social science research, 95% confidence level is universally accepted. So in most of the case, we apply 95% confidence level. So the cutoff value for checking the statistical significance in our case is 0.05. So any value less than 0.05 will be considered as statistically significant, and if the p-value is higher than 0.05, then we can say the correlation coefficient is not statistical significant. As you can see in this case, the significant value is 0.000, which is less than 0.05. So we can say that the correlation coefficient is also statistically significant. So in last, we can conclude that advertisement expenses and sale both are positively and strongly correlated, and this correlation is also statistically significant. So this is how we perform correlation analysis in SPSS. I hope this video will help you in your study, and this will make you understand the process of calculating correlation coefficient. So I just want to conclude here. So this is how you all can perform a correlation analysis. So thank you for watching.